Hello and thank you for joining me today. Today's video covers our key management system. This is a GPL repo link below. To begin, we must explore what kinds of keys and what kinds of passwords we're setting today. We store encrypted keys in the vault. The vault is simply an encrypted partition living on each home server. The rest of the partitions are not encrypted. This is so when the device boots up, users still receive full network capabilities. This has some obvious advantages. We know our keys are always encrypted in storage. A new key is generated when we pass into this script an application name, a username, and a password. It takes these credentials and feeds it into the provided binary. The binary outputs our new key into storage. Clobbering any existing keys by the same name, we begin to add a new key. It's going to ask if we are updating the vault password, updating the NAS password, updating the NAS backup password. Then it asks for a specific key operation. To explain these key operations, we must first explore LUKS itself. LUKS drives use a discrete key system where individual slots are assigned keys. When we add a new password to a key slot, it is taking a physical location on the drive. LUKS drives have a limited number of key slots. When we attempt to access an encrypted LUKS drive with a password, it will sequentially work through every key slot attempting your provided password. We can only fit so many keys on our own key ring. If we have a bunch of keys, it can take a while to go through them all on a locked door we control. Our three primary actions are to replace key slot 0, replace key slot 1, or simply add a key. When we replace the primary key, this destroys every key except for key slot 0. This ensures only your newly set password works on the device. Use with caution. Safe rotation action is the recommended action. This replaces key slot 1 perpetually, preserving your FAK or factory access key. Flexible addition adds the new key to any available slot. Edit has logic if no slots are available. To recap, we can replace the primary key, rotate key slot 1 indefinitely, or lastly add a key. So we must enter a valid password for the vault, for the connected NAS drive, for the connected NAS backup drive, and our new password. Our new password will be stored as a nas.key file in our vault. The original nas.key is generated at the time of your device's creation. When you create a new key, the nas.key will be updated to your new password. The password printed on the top of your device is stored internally as well as a skeleton.key file. This file decrypts the service suite key. The service suite key is only accessible once the vault has been decrypted. Therefore, the vault password is the most important password on the device. When a home server is fully set up, we would expect to find these keys in the vault. Let's explore how we retrieve our newly generated key. The service suite key is decrypted by the skeleton key. The service suite key decrypts our service keys. We support infinite service keys. To update a key on a drive is to apply one of these strategies to an existing drive, inserting the stored nas.key. For example, here we are adding our stored nas.key to our SDC device. The NAS backup. What that means is on sequential reboots, our home server will be able to decrypt both our NAS and our NAS backup. When you first unlock your vault, the nas.key is tried against any encrypted drives connected to the home server. In practice, this means that once you unlock your vault, all of your drives and services become active. Next, let's update the admin password. It takes the present password, which when you receive the device will be your FAK or factory access key, and your new password with confirmation, without any restrictions. Your new password will update all of the system's owner user passwords. We update the service suite key to be your new admin password. We update the SSH access password. We update the Samba access password. If any of these changes fail, we roll back the changes. This has been our introductory tour to our key management system. The GitHub repo is in the link below. Thank you for joining me today. Goodbye.